Anything, anyway. What? LinkedIn? Social networks are the typical graph relationship, graph network, right? Bobby knows Joe, who likes tacos, who went to school here, that, right? So what's really important for social networks is the notion of the relationships between those different elements. And what's great about that is by looking at those relationships, and with AI, you can then predict certain elements, right? So, an example, if Xander, likes a certain sport, a certain sports team, and goes out to a certain bar after the game or whatever, and then someone else who knows him also likes the sports team, and there might be a good chance that that other person would like to go to that bar also. So the values in the relationship. So key benefits of graph databases in AI. So graph databases don't replace anything in AI. What they do is they bonify what we've seen this morning, right? AI, LLMs, machine learning, etc. Right? Well, graph databases in AI, they help you bonify the contextual understanding, right? So naturally models real-world relationships. That relationship, again, is of utmost importance. Improved accuracy. It enriches your training data with relationship-aware features. So it kind of makes your data a little bit more intelligent when you look at it. Right? You dig a bit deeper to see what those concepts are. Greater explainability. Offers a traceable path of data flow and reasoning behind AI decisions. And efficient processing. It excels at managing complex interconnected data and covering hidden patterns. So an example, let's say you wanted to build LinkedIn through a relational database. And probably the first versions of Facebook or LinkedIn did actually use relational databases. The problem is that if you try to navigate the relationships in a relational type of pattern, you're never going to be able to scale. You're going to bring a relational database to its needs. That's why these very specialized type of databases were created. That's why graph databases for certain elements are the most efficient at processing relationships. And that's why they become so popular in the last years. So why Aerospike Graph? Well, take all the advantages of Aerospike that I talked about since the beginning this morning. Low latency, high throughput, infinite scale, lower infrastructure spec needed, and predictable performance, and then add all of that into graph, and that's why Aerospike becomes a great graph database developer. So the architecture, we're going to look at a very simple demo. It's a fun demo. So again, our cylinder, we're going to have an Aerospike database. We're going to have a Spring Boot Java service, which allows us to query the database in order to determine if we have fraud on our transactions or not. And then we're going to have a UI layer, which is just a next JavaScript and CSS. So we're going to have a simple UI, which allows us to create transactions, and then we're going to have the Java backend, which is actually going to be the brain behind our demo, which is communicating with our Aerospike database. The data model. So I talked about the different nodes we're going to be using here. So we've got three main nodes: user, account, and device. A user can have multiple accounts, or zero, and it can have multiple or zero devices. Okay? Now, I'm going to see if people are following here. Let's say we're doing a fraud demo, and we just talked about graph databases and how relationships can matter in terms of using those graph databases. In terms of fraud, if we look at user, account, and device, what are certain things that you think might help us either determine if fraud has happened or it might happen in the future, or predict it? What are certain elements here that you think could be important to look at? The balances of the account, okay.
Prior first payment defaults.
Payment defaults, right? Okay. Those are attributes, but let's think of the relationships. What relationship might be able to help us determine that?
Friendship with older poor people.
No, but you're onto something. Friendships or user relationships. You're onto something there. Those are more, yeah, but that's true, but those are attributes of the node. I want us to think of the relationships.
Lack of history for relationships.
So, an example. Peyton and Xander, you guys are transferring money. We're going to see this. I don't want to throw out the punch, but still, right? Xander is known to have frauded in the past. Xander, I did. Right? And Peyton is always transferring money to Xander. What could that potentially be without actually, saying that you're fraudster too, right? But what could that potentially be? Right? That relationship can help us determine, well, yeah, I don't want to throw him under the boat, but knowing you, Xander, has its risks, right? So those are things that we'll see in this demo. All right, actors. So here we are. So we've got 4 main actors. We've got Barbara Brooks, victim 1, and Bobby, or victim 2. So here we have their account numbers. We have Jennifer Bates, who's a fraud ring member. She's very convincing, by the way, when she talks. It's a little bit like Peyton when he calls, client, very, very convincing. And then we have Erin Barrett, who's the fraud ring leader. So you can see, nice friendly people, and these 2 people don't seem to be very happy and nice, right? So we're going to use their scenarios to help show a little bit how the demo will. All right, so let's get to showing you what this looks like.
Pay attention to what Greg's saying.
All right. So the first thing I'm going to show you right here is, so here's our dashboard that was developed in JavaScript and Tailwind, right? So this is all mock data, right, with mock people that we just populated Aerospike with these people. We have 10,000 users in the system, including the 4 persona that we just saw on the slide, right? So you can see each user has a location, an age, a risk score, etc. All right? Now, currently we have no transactions. Now this system, this demo, if ever you're interested, you can always download it off GitHub and play around with the code also, and we'll look at that together. We can generate some transactions, and we'll do that in a second. And then the admin section. So that's the UI. This is the front end right here. Now let's look a little bit at the Java code. So we said that the fraud service was built in Java, right? So here we have fraud. So I'll just show a little bit front-end Java backend. All right, so there's a couple of layers here. But the main layers that we have in the background is we have a graph service, which actually information on a transaction, which is, give me a second here, a transaction info object. And if we look at the transaction info real quick, let me see where that is. Fraud, the model, I guess it's a model, yeah. No, it's not there. Just give me one, I'll just have to see where this is. Transaction. That's not important. The transaction info object is just information on transactions. So it's going to say who was the user, which was the source account, where is the money, the amount of the transaction, the money we're using, and which account we're sending it to. And then what we do is we have a rules-based system, and each rule represents one of the fraud detection rules in the demo. So the first one here is, the first rule of thumb it will look at the graph relationships between the users and will generate a certain risk factor or score depending on the relationship between the individuals. All right? The next one it will look at is the accounts, the relationships between the users and the accounts, and finally the last fraud rule will be on the devices. So an example, Xander, when he's doing all his fraudulent activities, is using the same iPhone all the time, right? So if we were able to determine that there was fraud that had occurred on that device, then there's a good chance that if Peyton knows Xander, and you go down the relationship and see the relationship of his device, that there could be potentially fraud there too, right? So you look at all the relationships in order to generate that risk score. That's a different way of kind of calculating risk, right? When you're looking at fraud detection, this just goes to show you how it can be added to your fraud detection systems and in order to make them more powerful in determining the fraud. Okay. Now that we've seen the code, let's just go here.
So
Yes,
you pre-program the risks.
you can. Yeah, it all depends in terms of.
Or you
No, this is just, for now, the business rules here are just assigning a certain risk factor constant, right, in the code. So we're not doing machine learning for this demo, but yes, usually what you would do is you would have this connected to machine learning models, which would then bring you a predictive score on the risk. For here, we've just simplified it a bit to show a little bit, though, how the relationships of the graph can be used to show that model. Right? But you are right, usually this is going to be combined in a production system, probably with some ML learning, etc. Right? Okay, so the first thing we're going to do, let's go here. So Barbara, well, first of all, so Jennifer called up Barbara, and here's a use case. She said, I'm a financial advisor, and I've got really a great stock tip. You got to transfer me the money right away because, look, this won't last long, and you can trust me, Barbara, right? Jennifer's very good, and send me $5,000, and I'll be able to invest it for you. Barbara, being the good person that she is, right? She went and she transferred the money to Jennifer. Yeah. Transferred the money to Xander. All right, so here. So all I'm doing here through the UI is actually creating a transaction, right? So if we look at the transaction, everything seems clean, right? The reason why it's clean is that Barbara has no history of fraud. She had a very low risk score. And to tell you the truth, Jennifer just joined this fraud ring very recently, so her profile's been pretty clean also. If we look at the fraud analysis, right? Right now, there's no relationship between the accounts or fraudulent devices, so everything's good. So poor Barbara is out $5,000. All right? Now, the way this works usually is the fraud ring member will fraud, they'll work their whole 9 to 5, try to fraud the most money, and then that money needs to be transferred to central account. And that is Aaron Barrett's account. So Aaron talks to Jennifer and says, look, transfer me the money that you got today. Jennifer says, sure, no problem. I got $12,000 total, in which $5,000 was from Barbara, right? But before doing that, let's go look at something first here. Let's go look at Aaron's user profile. I just spelled it wrong. Let's see. 2 R's. And the 2 A's, 1 R. Oh. There we go. So look at Aaron's profile. It's critical. And the reason why is because Aaron's device had already been flagged for fraud in the past. So so the risk assessment is critical. Again, this score is just hypothetical. We use some very simple business rules to calculate this, but usually would use some ML models or something else to actually generate that. All right, so he's a very risky individual. So what happens here now that you know a little bit about Aaron's profile, Jennifer will transfer her loot to him in a transaction for $12,000. Oops. And she'll transfer that to Aaron. Great. Transfer. Now, if we look at that transaction, the risk score has been calculated at 85, very risky. And how was that done? Those business rules of the graph relationships was able to see that one of the devices that Aaron's used in the past was already used for fraud. So if we look at the fraud analysis, we'll see here that 3 connected accounts were checked. Aaron linked to Jennifer, linked to Barbara, right? Sender account with IDs, and flag devices right here. So by looking at those relationships, we were able to help determine that this transaction could potentially have a high risk for fraud here, right? Okay, so this is fraudulent. Remember at the beginning we said Jennifer had a very clean slate, right? So next day Jennifer talks to Bobby. Bobby is a hard-working person and he wants to get in the action of this hit stock, right? And Jennifer convinces him to transfer $2,000. All right, we'll just put 2,000 here. And this is going to Jennifer. Now remember, when Barbara transferred the money to Jennifer, right, it was clean. Nothing was natural. But in this latest one, because Jennifer already transferred money to Aaron, who was very high risk for fraud, the relationship between Jennifer and Aaron and now Bobby has brought up that risk score and thus flagged it for fraud. Now remember, when she worked with Barbara, there was no fraud, right? There was no risk for fraud. But because that relationship was created, now this one is risked here, and you can see 4 accounts have been checked: Bobby, Barbara, Jennifer, and Aaron. And because of Aaron's flag device, it's brought up the risk factor right here. And this is a simple example of how fraud with graph databases can be used. Now, for those of you who are interested, graph databases, there's an IDE for graph databases called G.V that you can use. And if you look at these queries, this is what we call the Gremlin query language. It looks a little bit different than SQL. I must tell you myself, I'm far from being a pro at this. But there is an Aerospike connector for G.V, and this is where I got a lot of the, we look here, the data model. Okay. So here is an example, a visual example of the data in the database. Now this is just 1,000 users. I tried 10,000, but my MacBook didn't like me anymore. Right? And if we would go deep enough, and if we'd find it, we'd actually find the blue arrows, which are extending from the user's accounts, which build the relationships of the graph database. So it's a great tool to examine your graph databases, and also this is how I got the data model. Right? So instead of making a model myself, I just connected through the Aerospike connector for G.V, and was able to get that here. And then just to show you, right, the code that I showed you in Java, what it really is doing in the background, it's converting my Java code into these Gremlin queries, right? So an example, if I go here, and I'll go get the transaction ID, and let's say I want to look at what really a graph query can do, I'll just pop it in here. If I can find it real quick. And and transaction example. And you can see that it returns the data in this graph query language. So here we have the source, the receiver, the transaction, and the fraud score for it right here. So if you look at the query, I won't go too much into details here, but here G.E means edge, has a label of transacts with the transaction ID as transaction. Vertice has labeled account. Vertice means relationship. Select transaction, select sender, and then print it out for me, right? Again, the graph query language is a little bit different, takes a bit of time to get used to. To tell you the truth, I generated a lot of these with generative AI because I'm just learning myself, right? But the goal here of this demo was to especially show you the power of graph databases and to always remember those relationships can help out in any business context.
Maybe we can talk offline, but how does this tie into the libraries concept that you teasered before?
Oh, actually, our client libraries do support the graphing capabilities of Aerospike, so I can talk to you about that after the show. Yeah. So what it actually does is through the, let's say, Java client or the Go client or the Python client, to simulate this query through Java code or through Go code, whatever code, Python code, and then it will convert that into the query that's needed by the graphing database. Alrighty. Any questions or comments on the graph demo? Is it kind of interesting? Was it something that, I don't know.
So the power to do this is in the database.
Uh-huh.
Graph itself
Yeah,
is just
it's a,
interesting. But
yeah.
it's not really useful.
No, yeah, I understand that. The thing is really what we wanted to show you here in the AI representation is, right, we're so based usually on either NoSQL or SQL databases and looking at the code itself and the value of, let's say, those values in the database, but sometimes we forget that those relationships in graphing can also add a lot of value when it comes to those AI type of use cases. And yeah, it was a different way, a quick way to kind of show you a little bit how graph databases can help in that fraud detection.
So that user interface.
Yeah,
That was built
yes,
outside.
yes. So here, this here, G.V is an IDE. So let's say if you're writing Python code in PyCharm or Java code in IntelliJ, this is actually, G.V is an IDE for graph databases. So you could connect to another one you had used. What's that? Neo4j, right? Aerospike. All of these graph databases, this IDE can connect to them and show representations and allow you to query them through this IDE. Does that help answer your question? All right. All right, everyone. So we're approaching the finish line for today. So Aerospike Cloud. So we've talked about Aerospike. You've seen all the great features. You've seen how it can scale, how it's highly available. You're probably starting to think of some of your projects, and saying, wow, I'd like to try to integrate this database and see what we can do, right? So there's two ways of actually installing Aerospike, right? You can go to our GitHub repo. There's a simple Docker image where you can spin it up locally on your machine. But what's coming out into preview is Aerospike Cloud. Now, Aerospike Cloud allows you to quickly create an Aerospike cluster and start creating databases without you having to manage anything, right? So if you want to deploy a cluster of Aerospike, let's say you want to do this on AWS, well, you have to create the EC2s, then you have to upload the software, then you have to install the software, then you have to configure security groups and VPCs and network connections and open ports and closed ports, right? It becomes a little bit of a headache. Now, Aerospike Cloud, which is in preview, will allow you to just log in. You will define how much data you have to store, the size of your data objects, your throughput, and then magically it will determine the infrastructure path. And it will install it for you, and it will just give you a URL to connect to that database. So I'll just show you all a quick preview of what that looks like. So I am now in Aerospike Cloud. I provisioned a cluster not too long ago, just before this meeting. So again, this is in preview mode. So for now, we have a cluster view in Access Manager. So Access Manager is where you're going to create API keys, create members who can access the database, what are their roles or privileges, right? And how they can use the different databases which are there. And then let's say you want to create a cluster. It's very simple. You click on Provision Cluster. You give the cluster a name, so we'll call it Test String. For now, we only support AWS, but very soon we will be supporting Google Cloud. So for those of you who have applications running on AWS or GCP, you'll be able to connect to your Aerospike cluster through VPC peering. And then there'll be other technologies such as Transit Gateway and support and all of that stuff coming down the road. So you'll choose your region. So let's say we choose US East 1. CIDR block, that just means a custom IP range for your nodes. We'll just leave it as it is for now. You can choose the availability zones. So an example, one way of ensuring a very highly available database is not to deploy it all in one availability zone, but to spread out the nodes you're clustering different availability zones. I'm going to ask a question, why would we want to do that in terms of availability? Yeah, disaster recovery. Right? We saw what happened to AWS the other day. The whole region went down. I don't know if any of you were on P1 calls trying to get your apps back up and realizing that AWS just, hey, right? The whole region went down. Peyton says, you weren't on that call, Peyton? Okay. So let's say we'll put the availability zones to 2, but usually, rule of thumb, if you're really working with a mission critical database, make sure to deploy it on multiple availability zones. Configure availability, replication factor. So Aerospike, right, when your data is very important, replication factor is how many copies of the data do you need, right? So by default, you're going to have your data source, and then you're going to want a copy of that data, just in case something bad happens. So by default, a replication factor of 2 is good, but if you're using strong consistency mode, we always say 3 is better. But again, the higher you put this number, the more infrastructure that's needed. 2 is usually good. Consistency mode, so we support both eventual AP and strong consistency. We were talking about that at noon, right? So we'll go available. And data storage, hybrid memory. Okay, but quick quiz, hybrid memory, what are the 2 types of memory we have in hybrid? And SSD, exactly. Exactly. So you can store everything in memory if you want, but the reality is if you have high amounts of data, hybrid is the way to go. All right, here's where you choose your instance sizes. So this is where, so this might be very similar to people who go to the AWS console. You spin up an EC2, you have an instance size. Now what's coming down the road is a sizing calculator which will help you determine, depending on your load, depending on your ops per second, what is the best infrastructure spec to use. Because for now it's kind of guessing. You can kind of say, well, I think I might need this, or I think I might need that. But just know that this is just a preview, and we will have a sizing calculator coming out which will help you determine what's the best infrastructure to use. So the infrastructure, right, it'll tell you how many CPUs, how much memory is on each node, etc. And then the cluster size, this is the number of nodes that you will have in your cluster. The higher the number of nodes in your cluster, the more throughput you can handle, and the more data you can store. So if you have huge amounts of data to store, then you'll probably need more nodes. Again, the sizing calculator, which will be coming hopefully soon enough, will help in determining the the best amount of nodes and which instance types to use. And that is it. Once you do that, you review your cluster, you launch the cluster, and give it about 10 to 15 minutes to provision all the infrastructure, install your database. Once it's ready, it gives you some statistics on its use, how to connect to the database, and other elements like networking, which allows you to create a VPC peer from your application directly to the database itself. So Aerospike Cloud is Aerospike Easy Mode.